Your lecture video for January 11th through 12th. Let's go ahead and get started. If you do now, your goal is to write the product of two square roots so that your answer when simplified is 12x cubed y squared. So I encourage you to pause the video there and try this on your own. All right, so product means multiply. So I'm going to be multiplying two square roots so that I get this when it's simplified. But I think it'd be easier to write this as a single square root simplified and then break it apart into these two square roots. So before I go to the two square roots, let me just try to write this as one big square root that would simplify to this. So I'd have to put a 144 underneath the square root so that when I took the square root of it, it'd become a 12. I'd have to put an x to the 6th, so that when I took the square root, that would become an x cubed, and then a y to the 4th. To have four y's there, so they pair off into two groups of two, and you get a y squared. All right, now I can break this apart, and there's no one right answer here. We can break apart these numbers however we want. 144, maybe we decide we want to split that into a 72 and a 2. X to the 4th, maybe we want to split that into x to the 5th and just an x. And then y to the 4th, we can do a y and a y cubed. And now I've fulfilled the request here. Write the product of two square roots so that your answer when simplified is 12x cubed y squared. So yeah, lots of different ways we could have split up those numbers. I like this problem because you really got to think through the vocab and reverse some of the problem processes we've been doing so far. Okay. Goal for today is to be able to rationalize denominators and distribute radicals. Why are we doing this? So we can get decimal approximations if you need to divide by an irrational number. That is sort of the whole reason for why we simplify the way we do. Is it comes from a time when we needed to get decimal approximations by hand. We didn't ever want to be dividing by a number with a ton of digits, infinite digits, that you'd have to truncate at some point. Anyway, here we've got another just simplify. I just wanted to show you one that had multiple variables and talk about a way you can keep track of this a little bit better. So with the 27, I'm still going to split that into just a 9 and a 3 because 9 is the perfect square. But with all these variables here, so that this doesn't get too messy, I'm just going to expand them all, so that I don't have any exponents left. And I actually find that this is a better way to keep track of everything. It's just m to the 4th, write out 4 m's. N cubed, write out 2 or 3 n's. And then p squared, write out 2 p's. All right, now this is a square root. So to get out of it, you can either be a perfect square, like this 9, which will become a 3, or you can make groups of 2. So I'm going to circle off groups of 2 of the same thing. So an m can get out here. I can make another group of m's and a single m gets out here. Make another group of n's and a single n gets out here. And then make a group of p's and a single p gets out here. Now regroup everything that got out. So 3 times m times n times p times the square root of, now write everything they got left behind, a 3 and an n. All right, and the last step is to take things like m times m outside and rewrite those with an exponent. That'll become an m squared. So now we've got 3m squared np root 3n. And that's the smallest radicand possible, so that is considered to be simplified. All right, now let's get into distribution. So radicals can be distributed just like any value in front of a set of parentheses when you've got multiple terms inside those parentheses. Here, check and make sure that these can't be combined because that would make our lives a lot easier. But 6 doesn't have any perfect square factors, 15 doesn't, they don't match, so they can't be combined. So we're going to have to distribute this term in front. And when I multiply 5 root 10 to 2 root 6, I multiply the 5 and the 2, and those become a 10. I multiply the root 10 and the root 6, and that becomes a root 60. So you multiply the coefficients, and you multiply what's underneath. All right, now 5 root 10 times negative 3 root 15 becomes a negative 15 root 150. And now check again to see if any of these radicals have perfect square factors and can be simplified. Our perfect squares are 4, 9, 16, 25, and so on. I see I can take a 4 out of this 60, make this 10 times the square root of 4 times 15 minus 15 times, I can take a 25 out of that 150, make that 25 times 6. And now for the 4, a 2 can jump out, and for the 25, the square root of 25 is a 5. And I'll just multiply those directly to the coefficients as I rewrite it. 2 times 10 becomes a 20 root 15, and 15 times 5, or negative 15 times 5 becomes a negative 75 root 6. So just like that. Okay, and yep, check again, no perfect square factors in 15 or 6. And that's our simplified answer. Can't go any further, these can't be combined anymore. All right, so let's talk about different ways that division can enter radicals. Sometimes it's useful to use the quotient property of radicals to simplify when we've got the division of two radicals. So square root of 18 over the square root of 2. If you put this together, you're allowed to factor out that square root and make this just a single big square root of 18 over 2. 18 over 2 can be simplified to be 9. Square root of 9 is 3. Just in the back of your mind, remember that's a plus or minus 3, but we're kind of ignoring that for this unit. All right, so that will work on a problem like this to help simplify things. So what I want to do here is separate the division of these coefficients, so the 4 over 8, and then the square root of 14 over the square root of 2 becomes the square root of, so single big square root of 14 over 2. Only do this if this can be simplified, so I'm going to write that. Only rewrite this way if the fraction can be simplified. And that's because our goal is no radicals in the denominator. The goal is no radicals in the denominator or fractions inside of radicals. All right, so if this didn't become a 7, we'd want to approach this a different way, which we'll talk about in a second. But that can become a 7, and then 4 over 8, that becomes a 1/2. So we've got 1/2 square root of 7, which we'll probably want to rewrite as square root of 7 over 2. Put that square root of 7 back on the top there. Whenever you're multiplying something to a fraction, you always multiply to the top. So square root of 7 over 2, there's no radical in the denominator, there's no fractions inside the radicals. We're done simplifying this one. All right, so what if only the bottom is a radical? We cannot use that property, the quotient property of radicals, to simplify this. So what we'll do is we will multiply by a form of 1. We'll multiply both the top and the bottom by the square root of 2. Because what we're doing to the bottom, we're doing to the top, we're not changing the value of this fraction. If we plug this into our calculator, we're still going to get the same decimal, but we're going to achieve our goal of having no radicals on the bottom here. So this becomes 3 root 2 all over. Square root of 2 times the square root of 2 just becomes a 2. The square roots cancel out. All right, and it looks almost a little bit more complicated because you picked up this 3 here. Now we got 3 numbers instead of 2, But the big deal is that the bottom is now rational. All right, let's try one like this. So quotient rule would be a bad idea here because 5 over 4, that can't be simplified. But square root of 4, that's just a 2. So let's not miss out on opportunities where this can just become a 2. And we've got the square root of 5 over 5 times 2. And that becomes the square root of 5 over 10. Now, if we missed that, we could have still gotten there by multiplying by the square root of 4 over the square root of 4. We'd get the square root of 20 over 5. Square root of 20, we can factor in a 4. And we would get 2 root 5 over 5. Here, I want to actually go through that process. So we got square root of 5 times the square root of 4 all over 5 root 4 times the square root of 4. That becomes square root of 20 over 5 times 4 equals, now we can pull out the 2 root 5 all over 20, divide the top and bottom by 2. Yeah, we still get the same answer, square root of 5 over 10. But yeah, don't miss out when you can just simplify radicals outright. All right, now more complicated examples. Bottom is still just a single square root. And again, I don't think I meant to do this. That can just become a 2 there. And get negative 4 minus 2 root 5 all over 4. Divide the top and bottom by 2 to get this a little bit simpler. We get negative 2 minus square root of 5 all over 2. No radicals in the denominator, so we're done. Okay, let's see our next one. All right, here we go. This is a little bit more challenging one. So now you've got 2 terms in the bottom, so just multiplying by the square root of 2 isn't going to get rid of that square root. What we need to do is multiply by something called the conjugate, which is where you take that middle operator and flip it. If it's positive, it becomes a negative. If it's negative, it becomes a positive. And this will have the effect that when we FOIL this, the first terms will be rational, the last terms will be rational, and those middle terms will cancel out. They'll be exact opposites. But whatever we do to the bottom, we do to the top. So I have to also multiply the top by 3 minus root 2. I like putting parentheses around both the top and the bottom. And now I'm going to distribute across the top and FOIL the bottom. So first outside, inside, last. And let's see what I get. I get 9 minus 3 root 2 on the top. All over. So first I get a 9. Outside I get a minus 3 root 2. Inside I get a plus 3 root 2. And then last, 2 times the negative square root of 2 is just a minus 2. Positive times negative is always negative, but the square roots cancel out. I'm left with just a 2. Now here, these terms will cancel out, and then 9 minus 2 becomes a 7. And we get our final answer, 9 minus 3 root 2 all over 7. All right, so let's label a few things here. This was the conjugate. And we are going to use it when the bottom has 2 terms. All right, so conjugate, used when the bottom has 2 terms. All right, but this here was still a form of 1. You can see that, yep, it's some canceling, nothing else to be simplified here, so we can box our answer. All right, I think we'll call that good for this video. I'll embed a few more for you to practice here, and have a good rest of your day.